Welcome back to video 6 on this section where we're looking at all these different angles. We're looking at sum to product, product to sum, double and half angle formulas, and then we're looking at a lot of different identities related to this. In example 13, we need to write sine of 2 cosine inverse of x as an algebraic expression in x. Now, remember that when you have a cosine inverse or any trig relationship inverse, we need to rewrite it by taking a step back and reminding ourselves what this is saying. This is saying that cosine of theta is equal to x. And then if I were to impose a cosine inverse on both sides, I would have theta is equal to cosine inverse of x. So remember that what's in here, cosine inverse of x, represents an angle measurement. I'm going to take this out again, but I need you to remember that, because if we now state cosine of theta equals x, we can write a relationship on a Cartesian plane. If theta is my angle and cosine of theta is equal to x, and we can write it as x over 1, that means that the adjacent side is x and the hypotenuse is 1. Adjacent over hypotenuse. That means that I need to find the side opposite. From previous videos, you should remember or recall that if you don't know what side this can be represented as, you can put a little question mark here and solve for the question mark using the Pythagorean Theorem. I know that the side squared plus the other side squared equals the hypotenuse squared, which means the question mark squared plus the x squared is equal to 1 squared. If I subtract x squared from both sides, I get the question mark squared is equal to 1 minus x squared. Now I need to impose a square root on both sides to get just the question mark by itself. So the side I didn't know can be represented by 1 minus x squared all under a radical. So I'm going to take this question mark away and replace it with the square root of 1 minus x squared. Now I have all my sides for this triangle represented, and I can now use identities to write sine of 2 cosine inverse of x as an algebraic expression in x. I'll do this first by writing sine of 2 theta is equal to 2 sine theta times cosine theta. That's my identity. And now I can replace the sine theta and the cosine theta with what I know the ratios are represented on this triangle. I'm going to replace the sine of theta with opposite over hypotenuse, or the square root of 1 minus x squared all over 1. I don't have to write the over 1. I'm also going to represent cosine of theta as x, because remember, cosine of theta is adjacent over hypotenuse, or x over 1. So I'll write that there. And now I have, just to simplify this a little bit, 2 times x times the square root of 1 minus x squared. Ta-da! There we go. Sine of 2 times cosine inverse of x is equal to 2x times the square root of 1 minus x squared. And we are done. And now let's look at example 14. We're asked to prove that sine of x times sine of y is equal to 1/2 the quantity cosine of x minus y minus cosine of x plus y. We'll have to recall our sum and difference for cosine identities or formulas before we can simplify this. I'm going to work on the right-hand side only. So the first thing I'm going to do is replace the cosine of x minus y with the identity for subtracting an angle from another angle related to cosine. Remember, cosine does not play well with others, and so cosine sits by itself. Cosine x times cosine y, and then it's also sine opposite as well. So this will be plus sine x sine y. That's this first part. And then I'm going to also replace cosine of x plus y with the statement for that portion or identity as well. Cosine x cosine y minus sine x sine y. Now I just have to simplify it and show that it will equal the other side. Through simplification, I'll have 1/2 cosine of x times cosine of y plus sine of x times sine of y. And now I'll distribute this negative through. Minus cosine x times cosine y plus sine of x times sine of y. And now I can combine like terms. Sine of x cosine times cosine of y and minus cosine of x times cosine of y add to 0. I also have sine of x times sine of y plus sine of x times sine of y. I'm going to rewrite this as 1/2 the quantity 2 sine of x times sine of y. And notice that 2 is like 2 over 1, and when I multiply the 1/2 in, these will multiply to 2 over 2, or just 1. And my final answer will have just sine of x times sine of y. So the left-hand side, sine of x times sine of y, equals the right-hand side, sine of x times sine of y. And I've proven it as desired. Let's go ahead and review some of the other product to sum formulas. I just proved the first one here, sine of x times sine of y, but you also have the product to sum formula cosine of x times cosine of y is equal to 1/2 cosine of x plus y plus cosine of x minus y. And also sine of x cosine of y, notice that they're two separate trig statements here, which is nice, because that will come in handy later, is equal to 1/2 sine of x plus y plus sine of x minus y. Again, all of these have to be memorized. They will be absolutely critical to know when you get to calculus. So memorize, memorize, memorize.